New images of 3I Atlas from Spain, Thailand, and Norway just landed, and they're all pointing to the same strange pattern. Not a breakup, not a collapse, something else.
Across 3 continents, cameras have captured 3 IATLAS like never before. From Spain to Thailand to Norway, astronomers are witnessing a visitor from another star system behaving in ways that defy expectations. Each new image adds to the tension, showing the object under different skies, yet hinting at something hidden within. As it moves closer, an uneasy feeling spreads. 3I Atlas is not just passing through, and its secrets may be more disturbing than anyone imagined. The unexpected update. The update on 3I Atlas arrived without warning. No one expected this new information about 3I Atlas, yet suddenly 3 countries reported fresh images on the same night. What made this moment even stranger was that the images came from Spain, Thailand, and Norway, 3 regions with totally different skies and weather. Still, every camera captured the same unusual behavior from the object. It was as if 3I Atlas wanted to be seen at that exact moment. The images did not show a breakup or any kind of collapse. Instead, they revealed something happening deep inside the object, something that did not match normal behavior of a visitor from another star system. This was the beginning of a mystery that astronomers had not been prepared for. To understand why these new images shook the scientific community, we must go back to the beginning. On July 1st in the year 2025, the survey telescope called ATLAS first spotted the object. ATLAS is an early warning system based in Rio Hurtado in Chile. It watches the sky for fast-moving objects that could one day come close to Earth. During a routine scan, it detected something moving at an unusual speed. The first report listed the object under a temporary name that scientists use until they learn more. It was called A11PL3Z. Very soon, researchers discovered older images that no one had noticed before. The Zwicky Transient Facility had already captured the object in mid-June. These pre-discovery images were extremely important because they allowed astronomers to calculate a more accurate path and understand what they were dealing with. The next step revealed the first major surprise. The path was hyperbolic. This means the object was not tied to the gravity of the Sun. It was only passing through our solar system and would never return. The only way this could happen was if it came from outside our solar system. With this confirmation, it received its permanent name. It became known as 3I Atlas. The number 3 marked it as only the 3rd interstellar visitor ever recorded. The letter I stood for, Interstellar and Atlas, honored the telescope that found it. From that moment, it became one of the rarest sights ever witnessed by humans. Only 2 other objects from another star system had ever been confirmed. For astronomers, this was a chance unlike any other. They studied its speed, its brightness, and its strange shape. Everything seemed normal until the recent update arrived from across the world and brought new tension to the story. The first signs of something wrong began to appear from Spain's quiet night sky. Spain's crystal-clear core. The observer in Extremadura in Spain had set up the camera for a long exposure which normally causes the stars in the background to appear as streaks of light. This happens because the Earth continues to rotate during the shot. Even with these streaks stretching across the frame, the central structure of 3I Atlas remained perfectly sharp. It held its shape in a way that did not match the behavior of a fast-moving interstellar object. There were no signs of cracks, no signs of bending light, and no signs of dust spreading outward. It looked clean and perfectly stable. This single detail confused astronomers because objects traveling at such high speed usually show some kind of stress. Either the light around them changes slightly, or the surface begins to shed small particles. In this frame, nothing like that happened. Instead, the center of 3I Atlas looked even stronger than before. The most surprising feature was an asymmetric glow near the forward axis. This glow had been seen before, but never with such sharpness. In the Spanish image, it appeared brighter with a clearer edge, as if something inside the core was becoming more active. The glow did not flicker or stretch. It remained steady and firm, which suggested a consistent release of energy rather than a random burst. Even more puzzling was the intensity center of the object. It looked extremely stable. The brightness was evenly distributed and did not break under the long exposure. This level of stability is rare for natural bodies moving through different conditions. It raised questions about what kept the core so firm and why its light behaved in such a controlled manner. The same strange stability appears again, thousands of kilometers away. Thailand's perfect ring formation. While the images from Spain had already captured the attention of astronomers, the observation from Rayong in Thailand deepened the mystery of 3 IATLAS. That night, the sky over Rayong was far from perfect. Thin clouds drifted across the frame, and the high humidity softened the edges of almost every bright object. Normally, these conditions would distort or blur the appearance of any fast-moving target, making it difficult to see details. Yet, despite the clouds and moisture, the frame revealed something extraordinary. The brightness profile of 3I Atlas matched the Spanish observations almost exactly. Its shape, glow, and intensity appeared consistent, as if the comet were behaving according to its own internal design, rather than being influenced by the atmosphere. At the very center of the object, the glow formed an almost perfect circular ring, a concentrated halo surrounding a darker interior. This was not the kind of random pattern that reflected light would normally produce. The ring appeared precise and controlled, hinting at an internal stability that seemed impossible for an object moving at such incredible speeds. Beyond this ring, the outer layers arranged themselves in what looked like stacked shells. Each shell radiated a softer glow, forming a layered halo that expanded outward. The layers did not blur together. Instead, they created clean steps in brightness that gave the object a strangely organized and deliberate appearance. Perhaps the most astonishing detail was the brightness gradient. When scientists compared the Thai frame with the one from Spain, they found that the changes in brightness from the core to the outer shells aligned with remarkable precision. Two images captured thousands of kilometers apart, under vastly different atmospheric conditions, matched almost perfectly. Such consistency suggested that some internal mechanism or force was controlling the light or energy release within 3IATLAS. Nothing about the pattern looked accidental. The more astronomers studied it, the clearer it became. This interstellar visitor was behaving in ways that defied expectation, as if it carried secrets not meant for Earth. As the world compares the frames, Norway captures something that changes the conversation entirely. Norway's twisting tail. The next major clue came from the quiet skies of Bordal in Norway. Compared to the long exposure images from Spain and the soft atmospheric frames from Thailand, the Norwegian observation was captured in only 1 hour. Even with this shorter exposure time, the level of detail was far beyond what astronomers expected. The most striking feature was the tail extending from 3I Atlas. It did not appear as a smooth and simple stream. Instead, it held a clear structure that revealed something new about the object's behavior. Along the tail, a faint curl appeared, almost like a soft twist running through the stream of material. This curl was not the result of wind patterns in the atmosphere or camera shake. It stayed consistent through the exposure, which meant it was coming from the object itself. The curl suggested that 3I Atlas was not moving through space in a simple straight line. It was rotating. A spinning interstellar object can cause material to be pushed outward unevenly, which creates exactly this kind of curling effect. The pattern looked natural for something that was turning steadily as it traveled. This new detail was important because it added motion to a picture that had previously looked perfectly symmetrical. The Spain and Thailand images had shown stable light patterns and firm inner structures. They gave the impression of a calm, steady object. The Norway frame revealed that beneath that calm appearance there was real movement happening. The rotation could explain why certain parts of the core glowed more strongly and why the outer shells were arranged in layers. It also raised new questions about what force was driving the spin and how it stayed so balanced across different conditions. With this new curl and the clear shape of the tail, Norway brought a new dimension to the mystery. The object was not only stable, but also active in a controlled and steady way. Observers soon notice another clue appearing far away in the United States. The Virginia Wide Field Revelation. The next major piece of evidence arrived from Virginia in the United States. This frame was taken with a wide field setup, which allowed the camera to capture a much larger portion of the sky than the earlier observations. Because of this wide view, the tail of 3I Atlas appeared far longer than in any previous image. It stretched across the frame in a thin, bright line that held together even though the object was moving at very high speed. Most tails from natural bodies begin to fade or scatter when viewed over such a large area. The Virginia shot showed the complete opposite. The tail remained clear, steady, and organized from end to end. Even though the emissions were faint, the structure did not break apart. There were no signs of sudden gaps or uneven clumps that usually appear when a natural object releases dust or gas. Instead, the tail kept a consistent width, as if a controlled force was shaping it. This detail supported what the earlier observations had already suggested. The object was active. It was rotating steadily, and that rotation was pushing material outward in a planned and smooth flow. The halo around the object seemed to be growing as well. Each new observation showed the outer layers expanding little by little, as if more energy or material was being released over time. Yet, the center of 3I, Atlas, remained completely untouched. No matter how long the exposure was, or how wide the field of view became, the core showed the same firm brightness. It did not flicker or weaken. It did not stretch or twist. It remained perfectly stable, which added to the mystery of how it could stay so calm while everything around it displayed movement and activity. When the global images are aligned side by side, the true pattern becomes impossible to ignore. With these images, scientists are revealing some chemical secrets of 3I Atlas. Surprising chemical secrets. Before these surprising images, the mystery of 3I Atlas deepened when the James Webb Space Telescope, one of humanity's most powerful observatories, turned its gaze toward the interstellar visitor. Using infrared spectroscopy, while the object was still about 3.32 astronomical units from the Sun and moving inbound, JWST revealed details that astronomers had only dreamed of uncovering so early in a comet's journey. These observations offered a glimpse not just at its appearance, but at the chemistry hidden within, hinting at the environment where 3I Atlas originally formed. The telescope detected a coma rich in carbon dioxide, far more than what is typically seen in solar system comets. Water was also present, along with carbon monoxide, carbonyl sulfide, water ice, and dust particles. The carbon dioxide to water ratio measured around 8.0, a value among the highest ever recorded in any comet. Such a high proportion of carbon dioxide indicates that the nucleus is extremely carbon dioxide rich, something that immediately set it apart from familiar comets in our own system. Scientists believe this unusual composition may suggest that 3I Atlas formed near the carbon dioxide ice line in its home system's protoplanetary disk. This is the region far enough from its star where carbon dioxide could freeze directly, meaning the comet's birthplace experienced conditions very different from those that formed typical comets around our Sun. Further studies added even more layers to the puzzle. Spectrophotometric analyses suggest that the nucleus of 3I Atlas may contain a significant fraction of metal grains in addition to its carbonaceous and icy composition. This combination of metals, water ice, and carbon-rich material is extremely rare. The metal content could explain some of the strange patterns in the coma, including how material is being ejected and arranged in the halos observed from Spain, Thailand, Norway, and Virginia. Some researchers even propose that energetic chemical reactions, similar to Fischer-Tropsch synthesis, could be occurring on the metallic and carbonaceous grains under the sun's heat, creating organic molecules in ways unseen in solar system comets. These discoveries paint a picture of 3 IATLAS as not just an interstellar visitor, but as a messenger carrying the chemical fingerprint of another star system. Its composition, rich in carbon dioxide, metals, and ices, challenges previous assumptions about how small bodies form and evolve in other planetary systems. The findings suggest that the building blocks of planets and life elsewhere can be dramatically different from what we know. What comes next? Between July and September 2025, astronomers closely monitored 3 IATLAS as it sped through the inner regions of the solar system. Ground-based optical observations revealed that the comet's brightness, a direct measure of its activity, changed in a predictable yet striking way. As 3I Atlas moved from about 4.6 astronomical units to roughly 1.8 astronomical units from the Sun, its activity followed a power law behavior. Dust production varied approximately as the heliocentric distance to the power of -1.8, meaning that as the comet got closer to the Sun, the amount of dust it released increased sharply. This rate of increase suggested a steadily intensifying response to solar heating. By late 2025, 3I Atlas has secured its place in history as the third confirmed interstellar object, following Oumuamua in 2017 and 2I Borisov in 2019. Yet, unlike its predecessors, 3IATLAS displayed strong cometary activity that immediately set it apart. Its coma and tail were prominent and clearly defined, streaming outward in ways that captivated both amateur and professional astronomers. The chemical and polarimetric signatures of this object were unlike anything seen before. While most comets in our solar system show a predictable mix of water, dust, and some carbon-based molecules, 3I Atlas revealed a far more exotic composition and behavior. Studying this object expands our understanding of minor bodies far beyond the solar neighborhood. Astronomers now consider that not all interstellar visitors are simple icy bodies. Some may be enriched with metals, chemically unusual, and structurally complex. Observations from powerful instruments like the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories have been ongoing since its discovery. These studies include comparisons with known comets, trans-Neptunian objects, and carbonaceous meteorites, helping scientists contextualize its strange properties within the wider family of small bodies. While 3I Atlas will eventually leave our solar system, the data it has provided promises to fuel research for decades. Its presence challenges long-held assumptions about comet formation, composition, and behavior. For astronomers, it is not just a passing object in the sky, but a messenger from another system, carrying dust, ice, and metals that formed far beyond Earth's reach. As 3I Atlas drifts out of view, the mysteries it carries may rewrite what we knew about comets and redefine what we expect from future visitors from the stars. And for now, everyone is looking towards the countdown to NASA's high-resolution reveal. NASA has announced that high-resolution imaging of the object is imminent. These images promise to be the clearest view ever captured of an interstellar visitor in motion, potentially revealing details of its nucleus, coma, and tail that no previous observation could show. Scientists are eager to see whether the unusual structures observed from Spain, Thailand, Norway, and Virginia will hold up under sharper scrutiny, or if even more unexpected features will emerge. Around the world, observatories are coordinating their efforts. Ground-based telescopes monitor its trajectory and brightness, while space-based instruments prepare to capture fine details in multiple wavelengths. Every new data point adds to a growing picture of a comet unlike any seen before. The asymmetric glows, layered halos, and twisting tails previously recorded hint at complex processes inside the nucleus, but the limits of current resolution leave much unanswered. Researchers hope the high-resolution images will finally confirm whether these features are caused by rotational activity, internal chemical reactions, or an entirely new phenomenon. The anticipation is fueled not only by the object's visual spectacle, but also by its chemical secrets. Previous infrared studies revealed a carbon dioxide-rich coma, a potential metal-rich core, and unusual polarization behavior. The high-resolution images could link these chemical signatures to specific structural features, offering a rare opportunity to connect composition with physical morphology in real time. Observers are witnessing the strange behavior of 3 IATLAS intensify. The coma seems to expand, subtle twists appear along the tail, and the energy patterns in the central core remain unnervingly stable. Every image deepens the mystery, suggesting that the object may be far more complex and active than initially imagined. As the countdown to NASA's high-resolution reveal continues, the world watches with bated breath. 3I Atlas is evolving in ways no one predicted, and the next set of images may transform our understanding of what an interstellar visitor can truly be. Thus, the global images of 3I Atlas reveal a rare and mesmerizing interstellar visitor, combining stability, motion, and chemical secrets in ways never seen before. Share your thoughts in the comments. What do you think this mysterious comet tells us about other star systems?